So we have this code here. One of the things before we uh, took the break was I said, what's going on here? So this calculating angles will receive two arguments, a result, a float array with the result. It is not returning it. You will see that it basically gets it as by reference, and then the result is ultimately placed into that wherever that reference was pointing to in the memory. So it does not return. That's what is happening here with the result. In the same way, this get rotation matrix from vector sensor manager has this function available to us, get rotation matrix from vector. It receives the vector, and that is what we will pass it. We'll pass it these three values that we are receiving here. We'll pass it here. And what it does is in turn it takes in another argument, temp R matrix. So basically rotation matrix, the temporary for temporary storage, we have created this here, this variable, declared this, and it puts it into that, and it does not return it. So basically what is happening is here we are passing all these arrays by reference. And then the function itself manipulates the value, and it gets changed wherever it was pointing to. It does not have to return it. In the same way, when we remap the coordinate system, it does the same thing. It takes this temp R matrix and puts it into the rotation matrix array here. So that is why we have declared it as a class variable. So this memory location is available to the system to manipulate. That's what's going on here. Now we have to figure out how to use this, and also what is this business of translate rotation matrix according to the new orientation of the device. So as we are moving the device around, it may, you may have been looking at it in portrait and then suddenly it becomes landscape and all that. So all those measurements, accordingly, they need to be transformed. And this is what it is doing, this remap. So here we need to find out what these arguments are and how to supply them. So let's do that. What we'll do is we'll look at the documentation for this function, remap coordinate system for the sensor manager, and see what it needs. Sensor manager. Let's just get sensor manager and then we will find this function, remap coordinate. Sensor manager. So all the function definitions, and what we are looking for is remap coordinate system, right? So this rotates the supplied rotation matrix. Supplied rotation matrix. So it is expressed in a different coordinate system. So you see we are supplying both of them, the incoming and the outgoing. We give it the memory space allocation, and it does the rotation and sends it back. So in our case, what we want is X and Y are basically which axis, and these are again static variables. So all we need is to specify which axis along which to rotate the coordinates. right? So what we said to begin with was we are going to ignore one of the axes. Which one was it? We said we are going to ignore the z. So we'll transform it along x and y. That's what we will do. Axis x, axis y. That should do our job. So how will we access this variable here? How do we specify? Note that it is actually a static variable in the same class, sensor manager. So all we have to do is sensor manager dot whichever axis we are interested in. Axis x and y. Okay, so far so good. We have this code here which will give us the angle of rotation. Now we need to access it. So we added this here now, in case you're still looking at this. So these two. And now what we'll do is over here, where we have the values available to us, we'll declare an R vector and a result. Two floating, two arrays, and get and pass them along here. So for R vector, we have these three values. I'm pretty sure we could just pass values here. But I don't know if the length of it is used anywhere. So what we'll do is we will just play along and say R vector equal to new is a floating point array. So we have to use that declaration, and same thing for the result. Okay. So now this here becomes our R vector 0. And now we can call that function calculate angles. And what it needs is the two arrays, result and R vector. Okay. All right. So this will give us the angles. So let's output them now. Instead of saying rotation vector readings, I'm going to change this to angles. And we'll print the three values in the result array, 0, 1, and 2. Okay, so this point, all that cut and paste of the code, what it did was it allowed us to just make one function call and get the actual angles. So now we can work with it. With the angle is, 90 degrees, we know that tilted halfway. And we know what to do with that ball of that we want to, that imaginary ball that was in the center of the screen. At this point, run your app and see if you change these angles in the emulator, if you start seeing in your output what is going on. Are you guys getting the some numbers? They
For
should be
me, the values are not same as the ones declared here.
here, right?
Yeah,
They're not the same.
no.
So what is happening is that it's actually computing the forces acting on it and then using that. The numbers should be here. It is minus 180, it's zero, all zeros, right? In this case, it keeps on reducing. That's what I'm also seeing. It keeps on going down by minus one. Every so often, it changes.
I have different values. My X values are increasing. I have like
Increasing.
87, but my Y is decreasing
Okay,
and Z is increasing too.
okay.
It's like 116.
I'm just going to remove this remapping and see what happens. Okay. Let's continue with this. We'll come back to this. What the deal with this is. I need to jog my memory, but let's see what is going on here. I think there is a reason why it keeps changing, and that has to do with the actual forces. It is, that whatever object is placed on that surface, it keeps on moving. So I think what is happening is it's computing that in real time, and it will allow us to show that animation even when the device has been tilted. So for the moment, let's just try to use this and see what we are getting in terms of the output in the result. So what we'll do is we'll take the X and Y values, the 0 and 1, and we will reposition this object, which is here, the hello world. So depending upon the value of X, it goes from minus 180 to plus 180. But what we are interested in is the rotation, only half of it, 90 this way, 90 that way. We don't care about it going, the full 360. So when it is between minus 90 and 0, we'll appropriately calculate a location and place this there as its X location. From 0 to 90, we'll move it to the right. In the same way, in the Y direction, the positive values will take it up, negative values will bring it down. So how do we do that? How do we take this object, this view, hello world, and move it around like that? How would you do it?
Probably I will try I don't know if in the Android Studio, but in the S code we can use like a position to point out where the view can be.
Yes, so like we saw there that those view modifiers can be used, right?
Yeah.
Yeah. So over here, let's see what our layout is, right? This is our layout. So we have this text view, and right now its position is determined using constraints, because this root view is actually a constraint layout. So constraint layout has one thing that can allow us to do this, which is called, you see these sliders here. This is the horizontal bias and this is the vertical bias. So we can play around with the bias. We can programmatically change the bias, either one of those two biases, and we can get the same result. So we don't then have to worry about the device size. We don't have to, whether it's a tablet or a phone, does not matter. Because if we say that it has to go all the way to the top, we just set the bias to 0 or the maximum value. So basically, it's a fractional value. It goes from 0 to 1. We just change it. This will give us the same result. So our job is to take those angles that we have got and change the bias of this in the constraint layout. So this is what we need to do. How do we do that? How will you get, how will you be able to do that? How do we get access to this bias business? You can see the value changing here. Layout constraint, horizontal bias and vertical bias. So as you play with this changes the horizontal and this will change the vertical. But how do we do it in the program? You want to take a couple of minutes and find out? You'll notice that I'm doing more and more of this, asking you to find things, because that will become a big part of it. If you work in this field, you will have to keep on asking these questions, because a lot of these things, there is so much in terms of functionality, features, implementation available, that it will be very difficult to know everything offhand by memory. So this is going to be a constant exercise to find out how to do something and then do it. And then maybe you remember the next time. Maybe you don't, but at least once you have done it, it becomes easier. The second time you just have to jog your memory. So take a minute or two and find out how to change the horizontal or vertical bias of a component that is in a constraint layout.
We can define layout dot vertical bias equal to float value. For example, if we take this, we can maintain like constant layout dot vertical bias.
So vertical bias of what?
But if we need to change it for text view, then we can make it like find view by ID into a text view. And I think we can write it like text view dot vertical bias equal to result of 0.
So good direction. First step is to get access to the view, and then from that change the bias. That's what you're saying, right, Sandeep?
Yeah.
So our text view, what is the ID? ID is text view with a small t. So let's do that. We'll say text view, And find view by ID, by now you should know, returns something. Okay, I have to give it a name. So find view by ID returns a value of type view. We'll cast it to text view. We may not have to do that. We could have just kept it as view. And now text view dot, what do we want to set, Sandeep? Set horizontal bias.
Yeah.
Do you see it?
Or check for vertical bias without set.
Okay, set vertical bias is also not there. So we need to do a little bit more than that. So why don't you guys find out what you need to do? Take a few minutes and find out. Yes, so I see we need to get constraint layout dot layout parameters. So Harry, have you got?
I'm just trying right now.
Okay. Okay. So try and then we'll do it. We'll do it for everybody. And the others can also keep on trying.
Yeah, I was able to do it with constraint layout dot layout params.
Mm-hmm.
It doesn't work perfectly right now, but I can move somewhat. If I change the constraint, it goes to the left most right now.
Okay.
Yeah.
Give it another minute or so. So the thing to keep in mind here is that this property, horizontal bias and vertical bias, is only available if the view is embedded, its parent, its container is a constraint layout. And that is because a constraint layout has an object called the constraints. It is those constraints that we want to play around with. That's what is happening here. So that is what we need to get to, the constraints object, and then we will be. Yes, so Harry has also got it going. So why don't you, Harry, let's hear the steps. You and Shahrukh both have it. So tell us what were the things that you needed to do in the code, and we'll do it here and see what happens.
Yeah, sure. First, you don't need to comment out the text wheel text. You don't need to comment out.
Okay, so we
And
need that.
yeah, so then we do constraint layout dot layout parameters.
Constraint layout.
Yeah, dot layout parameters. You can give a variable name.
Okay.
Yeah, then that equal to, because we need to cast the text wheel to the constraint layout dot layout parameters.
Okay.
Then we do text wheel, text wheel dot get the layout parameters. Yeah, it's a function. Yeah, get the layout parameters.
Perfect.
Then we can do the layout parameters dot horizontal base equal to some number. For me, I do like a 0.2 f, so that will move to the left a little bit.
Okay.
Let's do the result.
So yes, so we can just do the result. Now what is happening is that our result, right? It's a number between 90 well, actually minus 180 and plus 180. So this horizontal bias, it is expecting a number between 0 and 1. So we'll come back, we'll fix that. So in the same way we do vertical bias. So instead of using the result, what we need is, we need to calculate the actual bias, right? So the bias goes from 0 to 1, and our numbers are going from minus 180 to plus 180. So we have to convert that minus 180 to plus 180 into a range of 0 to 1. A little bit of mathematics is needed. So basically minus 180 is 0 bias, and plus 180 is 1 bias. So if we say, no, let is not Java, we're on float. So what we'll do is, from whatever number we have, we'll add 180 to it and divide by 360. You'll see what happens. So put this in a bracket. This should give us this behavior. So when result is minus 180 plus 180 will cancel out and we'll get a 0. At 0, it will be 180 by 360. When results 0 is 0, it will be 180 by 360. It will be right in the center. It will be half. And at 180, it is going to be 1. 180 plus 180 divided by 360. So we'll do that for both horizontal and vertical. And now we can place it here. Instead of using result 0, we'll use horizontal bias. And instead of result 1, okay, do we need to apply this back to the constraints? Is
Yes.
there another step? Okay.
Yeah, so you can just do text view dot set layout params and layout params.
Okay. So this is basically, in essence, this is what we did. We retrieved the text view and we got its layout parameters. So that's what gives us access to the bias. And it is an object of type constraint layout dot layout parameters because the parent view is a constraint layout. If the parent view was a relative layout or some other layout, then this would fail, the casting would fail. Okay, let's see what this does. It's going nuts actually. Can you see it? The numbers are too random. So we've got a problem with the code somewhere. Let me just change this. First of all, you see the rotation of the device as we go from 0 to 90 is what we want actually, the range. And this I had said before. 0 to 90 gives us the object should fall to the bottom by now. So what if it was here in the center at 90 degrees, it should go there. The same thing should happen here at plus 90. So maybe we need a range of 90 minus 90 to plus 90. To show it properly. So we have a couple of issues here. The values we are getting, I don't think they're quite correct. And the other problem is this angles. So I'm going to change this to 90. So it allows us to see the thing going all the way to the left. And if you change that to 90, you have to change this to 180. The bias. It is actually very odd. I don't know what is going on here. One reading is minus 136, and then y is minus 30, and the z is minus 145. And then suddenly the next reading is plus 62. So there is a problem. And I have a feeling that the problem is here in this. We'll find out what the problem is. But so far, are you guys getting this? Some behavior, some movement of that, the hello world. Is everybody seeing that? If you play around with the sensor here. So we are ignoring one of the directions. So that's why that one is not having any effect. Okay. So anybody not seeing this movement, the bias setting everybody's got? Okay, since there is no answer, then I'm going to assume that all of you are getting that. Perfect. Now what we will do is, so you will see that actually it used to be a little bit easier in Android. They made it more complicated. There used to be a sensor. This is my sensors documentation here, right? There used to be a sensor called position sensor. I mean, it's still there, but in this, there was one called orientation, and this would return the three angles directly that we were looking for. Now, the problem is, if you read the footnote, this sensor was deprecated in API level 8. And this sensor type was deprecated. So although this would be the ideal, see, this would give us the three angles and we would be done, and it would return the number in degrees, and we would not have to do all this jugglery that we had to do. But what happens now is, if you click on this, you will get a message that this constant was deprecated. Use this instead, get orientation. So the orientation takes in two vectors and it returns one. Okay. And we are using this get orientation. So that's what we are doing. We're using get orientation, and if we read the documentation, we'll find out what it is expecting as R and values. So when it returns, the array values are as follows. The values have the three angles that we are looking for. So this is, this is what we are doing. This is our purpose. The result is the second argument. which they call values here, and it has the three angles. And then we convert those to degrees using, they are in radians. So you will see here it says that the values are returned in radians. The range of the values is minus pi to plus pi.
Sorry, excuse me.
Sorry.
I think there's a problem because their value 0 is a z. But our value 0 is x, right?
Oh, you're right.
Yeah, because I think that maybe is a problem because when we pass the value 0 we pass is x.
So what is
Because the R matrix is a result which is a return from uh I don't know which function.
it comes from here. The result is actually we are passing it uh, as an argument that comes in, and it gets populated by the orientation, and then again it gets converted to degrees. It gets converted in place. So it receives this and it modifies its own value.
I mean for the R matrix. I mean where's the R matrix come from?
So our matrix, when we call this remap coordinate system, it takes this temp R matrix, which this is a bit convoluted code. The way they have implemented is that they don't return anything.
Oh, okay.
Take
Okay.
the argument that was to be returned is actually passed as an argument, and it gets modified in place wherever that function is. When it comes back, it has got the new values in it. So the next line of code uses those new values and passes them as an argument to this. And this one calculates everything and incoming argument R matrix, it modifies it, and when it comes back, it has the new values. So this is a bit of, this is something that you would have seen a lot more of if you did C++ or C. But in Java, this is unusual, and they've done it this way. There must be a good reason. So my thought right now is I am not sure if this is causing a problem, this remapping. I just want to try it without the remapping and see what happens to this. At least the behavior is more consistent, you see. The values are not going nuts. So these are all zeros, okay. It's a bit puzzling as well. See, right now it has gone and gravitated to the top when it should be in the center. Okay. What we can do is I don't want to also spend too much time on this. Y, Z. Let me see if I remember. Wait, vertical, and okay. So this is pretty much what we were meant to do. I will need to figure out what is going on here, why it is not behaving exactly as we want it to. Okay, I'm going to open the one I did, the app I did as a practice run. this is the line that I have a doubt about, and yeah, it wants X and Z. So maybe that's something. Okay. Also, what is happening here is this emulator, we have a vertical screen here where we are looking at it. So I don't know if this XYZ that I am perceiving is different in the emulator. Generally, on your phone, you would be, when you're designing something, you would be designing it with this kind of a plane in mind. In the emulator, it's like this. And I see that in the code here, I've got X and Z. That might be because it's the Y rotation when the device is like this. What we are ignoring is this rotation, which is the Y axis. So let's give that a try. I'm going to change this to X and Z. Okay. Suddenly the values make more sense. Minus 180, 0, 0. But it's not doing anything. Okay, guys, I'm sorry. I apologize. I need to actually figure this out myself. And what we will do is we have brought it to a point where okay, where we have the ability to manipulate an object using this sensor. It's not even changing anymore. It's always 0, which is what I wanted to see to begin with. Anyway, uh, this is something I will find out what is going on and have an explanation for you. Kind of teaches us one more thing, that some of these sensors can be a little bit tricky to use. And I know that you guys are doing an entire course on game development, right? Using Android. So is it the game development course that Steve is teaching? Are you mainly using it on Android or is it cross-platform?
Well, right now we haven't started yet. We're using Unreal Engine, and the only thing we made is desktop app, and we made Android APK. So maybe we'll continue for Android because we're thinking about doing the final project would be AR and VR.
Mm-hmm.
I think it's easier with Android with the headset, but it depends because not everyone has an Android phone. So I don't know how that's gonna work.
Okay, okay. So you will see techniques of doing such things that the game engine exposes in an easier to use way. But it is a part of our advanced Android syllabus on how to use these sensors, how to set them up. So of course we have to cover it. And the main exercise here was to be able to read different types of sensors, see what values come back, and how to apply them, how to use those values. That was what you should have gotten out of this, the two activities we did. One is to use the light meter, the ambient light meter, to change the screen colors, etc. That was one. And the other part was using this rotation vector and to to use it in a way that we could show something here. Those of you who have an Android phone, you can plug it in and you can see if you get different readings. Actually, I might do that. Just give me a second. Actually, I won't be able to do that right now. Okay. Any questions with this? Ignoring the one that we have a problem with setting up these angles properly, that I'm going to have an answer for you next time. But other than that, do you have any questions about sensors and how to use? So same philosophy, any other sensor, exactly the same philosophy you will use and do what you need to do. Proximity sensor, same thing, you will receive a value, you will know what to do. Okay. So this here was what we wanted to achieve at the end. There is some homework for you here. And this will become, I will post it in Blackboard. So what I want you to do is, this homework has two components. One is I want you to use a different sensor, a temperature sensor. And once again, within these virtual sensors, if you go into additional sensors, you will see there is one for temperature somewhere. It's right here. So you will use that sensor and you will replace this text where it says hello world with the actual temperature. And your submission will actually be, I don't want you to submit code, etc. I want you to make a movie in your emulator. Do you guys know how to make a movie on your Mac? Record the screen or a portion of it? Okay, so I will show you that as well right now. This is how you will do it. It's actually fairly straightforward. Is anybody using a Windows computer, not a Mac? So you're all using a Mac, right? So Harry, Command Shift 4 allows us to take a screenshot, right? And I've never used Command Shift 5.
If you look at the bottom, it will give you an option for like a recording.
Right. So yes. So Command Shift 5 gives you the ability to choose the area that can you guys see my screen? I'm doing it right now.
Yes, we can see it.
Yeah. So I did Command Shift 5 and it presented this crop box. So you can place it around your emulator and the sensors. Record selected portion, record entire screen, right? So we don't want a screenshot. We want to record a movie. I want you to show your app here. I want to see your name. And then I want you to change this ambient temperature. So if I click on this button here, which says record selected portion, does it give me an indication? No. So this is okay.
You have to press the record button
Right.
and it will show indication on the top.
Very good. So now it is recording this, whatever was in the crop box. So I want you to record and don't make it too long, like 5 or 10 seconds is enough. You record that portion. I've done the recording, and then there is this at the top, stop recording, and you press that, and it is going to record and save it on your desktop. So that is your submission. And if I play this movie, it shows me, yeah, it will show me the cursor going around, changing the temperature, and the display should change accordingly. So this is a sort of one of the ways we will have more submissions of your assignments. Makes it easier to see the final product.
So we have to work with ambient temperature.
Yes, so that is your homework. It's going to be implement another sensor, the ambient temperature sensor, and change this text. When you receive events from the ambient temperature sensor, you will change instead of hello world, you can just display the temperature or say whatever, new temperature or the current temperature
So, like,
is.
can we do a value, right? Dot Celsius, and changing this just changes that value and just presents that, or we can change.
Yeah, for the text view you're talking about, right?
Yeah.
Text view dot whatever the function call is, set text.
Okay.
Yeah, you will do that. And the part that you are going to be focusing on, that's the main focus, is to obtain the ambient temperature sensor and start listening to its events and process them in the function. And then you will submit this movie. Blackboard is very, stingy when it comes to how much space it allows people in terms of total uploads. So make sure that your movie is not more than 5 MB. It says 5.3 megabytes on disk. Something like that is okay. If it gets too big, record another one that is a bit shorter. Or or trim it using QuickTime. You can trim movies. Okay. Is that clear? How to do this part, making the movie? Okay, perfect. So this time I just I tried a different way of delivering the class, in the sense that in the previous classes and those of you who took the course last semester, it was actually, one difference was that we were in class, so a lot of the activities were easier for me to also, I could walk around and see what is going on. If somebody, if I were to ask you to do something, I was right there. And you could raise your hand and ask me a question. Okay, I'm trying to do this or that. And all of that is, with this virtual format, that is a lot more difficult. So I wanted to experiment and try a class where I ask you to do more things rather than showing it to you right away. And also, one other change I made today was I moved a little slower than I'm used to moving. So with the hope that it is easier to follow and easier to, it is, the pace should match what everybody on average feels comfortable with. So what I want is, I want you to give me, if you have some feedback to give, please email it to me. I don't want you to post here, so that you can feel free to say what you want to say here. One other thing is, even if you send me a private message in the chat, when I look at it, everybody can see it, right? Because I'm sharing my screen. So if you felt that the class was at a good pace, please let me know. And do let me know if you felt that it was too fast or too slow. I'm not saying that we will change it. I want to, we have to, it's possible that for some of you, maybe you felt that it was moving too slowly, but if the majority feels that it was a good pace, we will keep it like this. And those who find it was a bit slow can write to me, and we will find, to make it more entertaining for you. Maybe you can, focus on some other things. I can let you know. So I want some feedback on that. This was a different, totally different way for me to deliver also, where I ask you to do more things. Okay, I have not prepared anything else for today, but our next topic is going to be notifications. So we'll be working on notifications. We'll look at both aspects, Google's own way of doing it, and there are some third-party frameworks. Google has its own Firebase, which works for both iOS and Android. So we'll look at that, and that will be our next topic. So any suggestions for what kind of app we could work on? In notifications. Okay. All right. Any questions about today's class?
The notification one, are we gonna use like Google notification or some other or a built-in notification?
So what I would like to do is show you what different options are. We'll talk about them, but we'll pick one and do that.
Okay.
We'll work that way. We won't do it in multiple different ways. And these days, what is going on is that most apps will use a third party, a messaging system. So, for example, Firebase is an example.
Yeah.
I'm pretty sure Amazon has its own some notification service. You could use an Amazon API. Yes, so yeah. So that way, Shahrukh, we'll look at what are the different possibilities and we'll pick one and then we'll use it. I think it makes more sense than trying to do different ones because the strategy is the same, methodology, how it works is usually the same.
Yeah, so yeah, definitely
Yeah.
it's more common to use Firebase or because they can send a global notification. Yeah. In-app
Yes.
notifications are usually for your app, like games and stuff, like if you finish a level. But
Yeah.
those general notification could be sent to every app.
Yeah, yeah. And yeah, you brought a good point. There are local and remote notifications.
Yeah.
So for that, there may be slight differences as well. So Michelle is asking if for the homework we use the same sensors app that we have been working on. Yes, please use the same app. Okay. If you guys have any questions, if you want to ask anything, I can stick around. If not, we are at 12:40. We have a few minutes to go, but since I haven't prepared anything, I'm happy to let you go a few minutes sooner. But I can stick around if you want to ask something, if you have any doubts about the class or the project. So I'll be here for a few more minutes.
I have some question about the final project. So when is the due date for the final project description?
I will create a Blackboard item and I will give you until the weekend, Sunday.
Okay, sure. I don't know, sir, if you have a chance to talk about talk to the other teachers in our program, like can we use the same project for the other teachers course for the final project?
So we are going to have a meeting tomorrow of all the faculty members. So I will raise this issue. And those of you who are taking both Android and iOS, that I've already said that I actually prefer that you use the same, develop the same app in both platforms. So what are the other? So there is a capstone project, Aniket has just mentioned. So I think it is quite okay to use one of these apps that you're developing in Android or iOS as your capstone project. provided that the capstone project is Rob is in charge of that, right? So provided Rob is the specifications of your app, everything are acceptable to him, then of course you can use. I think he would want you to use one of these apps as your capstone project. So that is a question for him as well. So in our staff meeting tomorrow, in our meeting, we'll talk about this, and I will let you know, or maybe by then you would have had a class with Rob, and he would let you know what is going on. But it makes a lot of sense to not have to do another app just for the capstone.
And also, I have some question about our iOS class.
Okay.
Yeah, I mean, like in the future of class, can we use more the Swift UI than the storyboard? Because I really right now get interested in the Swift UI because I feel like this Swift UI is much better than the storyboard.
That's what I think we will do because it's more modern. We used the storyboard in the first activity, mainly because, I just wanted to make sure that both aspects are covered, that you're familiar with both. I mean, maybe many of you have already done this using, apps using storyboard in your introductory course. But it's a good suggestion, and that's what we will do. Well, from now on, rest of the course we'll use Swift UI.
Okay, thanks.
Good. Anybody else? Questions? All right.